Hello everybody, today we'll be doing same tree. This is an easy problem. Given the roots of two binary trees, P and Q, write a function that checks if they are the same or not. Two binary trees are considered the same if they are structurally identical and the nodes have the same values. Okay, so in this first example where we have a root node 1 and a left node and a right node of 2 and 3, they are equal. However, if we have a input of 1 with a left node and 2 with a right node of 2, then we are false. As you can see here, this has a different value, and so it is also false. So one of the base cases that I want to suggest is going to be a base case where we are looking at a no item. When we're looking at no item and no item, we should return true. And that's basically the base case because there are a minimum of 0 items. And yeah, we have to handle that. And there's a maximum of 100 nodes. So I think that's all of our base case. And the time complexity that we need to do is going to be O of n because we have to visit every single node to check the value if we are going to get the whole tree. If we can end early. Basically, if there happens to be a case where it does not, return the same value, then we can return false immediately and end this whole business. So let's take a look at the space complexity. What is going to be our space complexity? It's going to be O of log of n, because the reason for that is because we're doing recursion. We're going to check this particular node, and then we're going to check the next two nodes, the left and right node, to see if they're also returning true or false. So because that's the case and we're doing this depth first search, we're going to go all the way down to the tree and then go back up. It's not actually log n. It could be just the height of the tree, because the height of the tree could just be a single path of the tree. It just could go down the left side. It's basically linkless at that point. It will be O of n if that's the case. But to be more exact, it's going to be height of the tree. So with that, let's think about the matching. So how are we matching? The match is basically recursion. And what's the plan? So reach the base case of no node, then return true. So first things first, if like this p dot val and q dot val are not equal, return false. Otherwise, return p. This is same tree of p and is same tree p dot left equals is same tree q dot left and is same tree of p dot right equals is same tree of p dot right. I think with that we would recursively look into the left and right node until we hit true or we end up with a false, and we immediately return. So let's try that out. That's our plan. We don't know if it'll work, but we have to try, because, well, I mean, how are we going to be more clear about this? So let's check it out. So if not root, if not p, and not q, right, return true. Else, if p dot val does not equal pq dot val, return false. Otherwise, return left node is equal, which is equal to is same tree of p dot left equal is same tree q dot left, and right node is equal is same tree p dot right equal as is same tree q dot right. Then we return left node is equal and right node is equal. This is going to be slower because, recursively speaking, this is going to cause a problem. The problem is that what happens is that we compute the top part and then we have to compute the next part. If the first part is, if we process this here instead, right here, then that means that if it's false, then we no longer need to do the next part. So that's the difference. So let's run the code. And where's Q? Apparently there's no Q. Positional argument. Oh, right. My bad. I'm using the function incorrectly. So this is going to be running slower. Let's submit this. Uh-oh. We have an issue. So, okay. So because P and Q let's write yeah. There we go. That should take care of all the cases. Let's move this to the top. And then run the code. Whoops, there's a problem here. Wow, that is unusual. I don't know why that is false. I see. Yeah, that should resolve all of the issues, but it is not clean, so we'll have to fix this code a little bit later. So it does look like it works with all our edge cases. Let's run our last edge case, which is this one here. And then let's submit it. We do have to fix some of this code. It is going to run a little slower, like I said earlier, if we run is same tree left and right, because it will have to run this one and this one before it intends to fail. So let's start fixing this code. And as our evaluation, we do have to arrive at every single node. So O of n time. And it's going to be, space is going to be O of the height of the tree because of recursion. So let's start optimizing this code. First thing, we're going to return this line of code. Let's see how that speeds things up. Submit. See, that's so much faster. And let's check out like how we can deal with this code and simplify these parameters. So there seems to be a lot of false. And I'm thinking about like how I can make this simplified. Give me a pause. Okay, so the idea here is that, so if P and Q and the values are equal, then we'll return this, otherwise return false. Let's see how that will look. Because if there is no P, if there's a P and not Q, or Q and not P, it will return false. And also, if it's not equal, then we return false. We can take all three of these and think about the opposite. So like if P and Q and P dot val equals Q dot val, then we set it to return this value. Otherwise, we can just return false immediately. So that will reduce the number of checks. Let's submit that. Okay, it looks a little bit slower this time, but it should have been faster. I think it just has to do with the type of code that we have. Can we simplify this some more and make this look better? I'm not sure. Can we swap these? I think so. It doesn't matter which way it goes. Let's swap it. Oh, so much slower. Why? Well, if we do swap them, then we check all of these first, and then we always return, and then we check this. But if we check this instead, would it be a little faster? I think so. Okay, I think we'll go with this. This is probably our fastest run. I think we'll have to just run this many times to make sure that this is the fastest way of doing it. But it looks like what was fastest was our multi-layer code earlier. Well, with that, we could try like writing the code like this as well. I don't know if that's a little bit clearer or less clear about what we're trying to do, but I mean that's also works. So there's a lot of ways to write code, and yeah, there are many ways to write code. But in terms of recursive code, I think getting to our base case is important. So, and that does not signify a base case. This signifies as a base case. And this here signifies whether we should move on to the next step or not. I think this is the best code right here. So if you have better code or another different way of typing this out, please comment below and let's share our learning. And if you enjoyed this video, like and subscribe. Want more videos, check the link in the description below. Thank you very much. I'll see you in the next one.